steps and whatnot. I'm not going to go through those formally, like read through all of them. You guys can read through them later. But I'm going to go through and actually show you how those steps work. And then you always have it as a reference if you ever need to look back to how you solve it. Okay, so step one to do synthetic division is you have to set it up. So this one, of course, is already set up for you just to get you started with the first one. But you're going to have to usually set this up on your own. So let me explain how the setup works. You're going to draw this upside down looking division bar, and then on the outside is going to go your divisor, or rather the constant of your divisor, and then on the inside is the coefficients of your x term. So we have the coefficient of x to the fourth, which is 1. We have the coefficient of x squared, which is 10, the coefficient of x, which is -2, and then of course the constant. Now you're going to notice there's a 0 here. What do we call that? A placeholder. And it's a placeholder for the x to the x to the third. So placeholders exist in synthetic division as well. So that's why that's there. All right. So now that we've addressed that, where all this comes from, let's talk about the number on the outside. So the number on the outside is just the, if it's x plus 3, it's always the opposite sign. Okay, so it's going to be a -3 on the outside because it's the opposite sign. So the reason for that is it's as if you set this equal to 0 and solve for x, you would get -3. That's what goes on the outside. So here's how the process works. Step one is you need to bring down your first coefficient. Once you bring down that coefficient, you're going to multiply it by the number on the outside, and that's what you're going to write here, which will become what? -3. Then you're going to combine straight down. You always combine as you go down. What's 0 plus -3? -3. And now you just repeat the process all over again. -3 times -3 is 9. Now you're going to combine, and that's going to become -1. Then you're going to repeat it again. -1 times -3 is +3. Then you combine and you get 1. Then you multiply again, and you get -3, right? And then you combine again and you get 1. So I like to put this little notch at the end of mine here because that last number you get is actually the remainder. Okay, so whatever you get as your very last number is always the remainder. So let's talk about what the other numbers mean and how you can interpret them. So the number directly to the left of the remainder is always your constant. Okay? This one is going to be the coefficient of x. This is the coefficient of x squared, and this is the coefficient of x cubed. Now, you could also have had more. Keep going, right? So if we had one here, what do you think it would be? Good, and this one would be x, and so on. Okay, so it always goes constant, and then it just goes up a degree every single time. So here's how you write your quotient. It's going to be the coefficient of x cubed with x cubed, so it's just x cubed minus 3x squared minus x plus 1. So that's your quotient. But not only you have to write your quotient, you have to write your quotient with your remainder over your plus divisor. Good. So your constant right here, and then your remainder over your divisor. So when you go to write your divisor, you're going to write the whole thing, not just the -3. Okay, that's very important. So make sure you write the actual divisor that we divided by. So any questions about that? We're going to do a bunch more of these, so if you're like still a little bit unsure about the steps, we're going to see plenty more examples. Yes?
Wait, why is the divisor negative?
So when you do synthetic division, you always write whatever that number is as the opposite sign.
Okay.
Any other questions? Okay. So the next one, we're going to go ahead and use some more synthetic division to find the quotient and the remainder. So it's set up for you. I like to, like I said, put this little other notch in here because that helps me separate the remainder from the rest of my answer. So what's going to go in this little box here? Good. Here's going to be a 2, then a, and then 15. You want to make sure that your last coefficient lines up with that box. So you're going to, yeah, go ahead. It's whatever this number is, but the opposite sign. Exactly. So you're going to bring down the 2, which gives you 2. Then you're going to multiply negative 3 times 2, which is negative 6. Then you're going to combine, which gives you good. Then you're going to multiply, which gives you 9. Then you're going to combine, which gives you. Then you're going to multiply, which gives you negative 15. And when you go to add these, you get good. So the remainder is 0. What that means is not only is the divisor a factor of your original dividend, what you're dividing into, but also the result is also a factor. So this represents the constant, the x, and then the x squared. Okay? So how could we write that as our quotient? Good. 2x squared.
Minus 3x.
Good.
Plus 5.
Plus 5. Very good. Now, since the remainder is 0, you don't have to write plus the remainder over the divisor. You only have to do that when the remainder isn't 0. But this basically just means that both the quotient and the divisor are factors of this polynomial. Okay? So if you were to multiply these two together, that would give you this. That's how you could check your work theoretically, right? Okay. Next one. What's going to go on the outside?
Positive 2.
Positive 2. Here's going to be a, then a, good, then, and then what? 0, because we need a placeholder for the constant. Okay? So now you're going to bring down the 3. You're going to multiply 2 times 3, which is, you're going to combine, which is, you're going to multiply, which is, good, combine, good, and multiply, combine. So our remainder is 14.
Wait, what do you multiply?
On which one?
Where do you multiply?
Every time you bring a number down,
You're multiplying
by this. Yep, exactly.
and then you use that.
Yes. So our answer is going to be 3x squared minus 2x plus 7 plus our remainder over our divisor.
What happened to the
Why
x
isn't it
cubed?
7x?
Wouldn't it be x cubed?
No. So, guys, every time your, whatever this number is your constant, and then it goes up a degree. So x and then x squared. There is no x cubed in this one. X cubed would have been if we had another.
I was taking the
Oh, yeah, you don't want to look at the original. If you want to like think about it like logically, you're dividing an x to the cubed divided by x, which is going to end up resulting in x squared. Okay?
So 7 doesn't have a variable.
No, the first one will never have a variable next to it. Okay, so something else I want to just like briefly mention. We'll talk about this more, but there's something called the remainder theorem. And that basically means that if you were to take whatever this number is out here, if you were to take 2 and plug it into the function, you would get whatever this remainder is as your answer. Okay, so that's a way you could check your work. That's the remainder theorem. So if you were to plug 2 into the original function, you would get 14, same as your remainder here.
It says 14x minus 2, right?
Yes, it does. Okay. So another way this question could be phrased is like this. So if you have something like this, is x plus 2 a factor of x squared minus 6x minus 20? We check that by doing the division. Okay, so it's another way of phrasing the question. What's going to go here? Good. Inside is going to be?
1.
Uh-huh. And?
Negative 20.
Negative 20. Start by bringing down your 1, multiplying, combining, multiplying. So the most common mistakes that I see with this is just simple, like, add instead of multiply, something like that. So anytime you get this wrong, before even checking with a partner, checking with me, checking with the key, just go through and just try it again. You know, I make these mistakes too sometimes with this, so just be diligent about that, especially on a test or quiz. So your remainder is -4, and your quotient is going to be x minus 8. Remember, this is the constant, this is 1 up, plus -4 over x plus 2. So is x plus 2 a factor of that polynomial? No, because the remainder is not 0. We're going to do one more together, and then you're going to get your homework. So we're going to put what here? Good. On the inside?
1, -4,
Good.
1, -3.
Good. Bring down the 1. Multiply, we get? Good. Combine, we get? Good. Multiply, we get? Combine, we get? Multiply? Combine, we get? So our remainder is? Good. What's our quotient? Good. 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 Plus -8 over, oh, I used x instead of b. I do that all the time, sorry. I'm just so used to writing x that it just throws me off. Sorry.
If we didn't use the same variable as a question, would that be wrong?
On the homework I wouldn't care, but on the test, yeah, please make sure you double check that, for sure. It happens, but just like when you go, you should always be double checking your work. Just make sure you read over it. So is it a factor?
No.
No. Alright, I'll hand out homework. And then a few of you I missed